After we understand the structure of directory, we are now going to discuss a vital concept in operating systems known as file system mounting. To access any file system on our computer, it must first be mounted. But what does mounting mean? Mounting is the process where the operating system makes files and directories on a storage device available for users or itself to access through the system's directory tree. The mount point is a specific directory in the already accessible file system where the additional file system is made available. On the slide, we can see an illustration of this concept. We have root directory, represented by the slash, and within it, we have the mount point highlighted. We can mount those unmounted partitions at this mount point. There are various timings when a file system can be mounted. It could be at boot time, where certain file systems are mounted as part of the startup process, or it can be mounted automatically at runtime by the operating system as needed. For instance, when a USB drive is inserted. Lastly, we have manual mounting, which is done by the user or system administrator, often through command line instructions. This gives control over when and how file systems are integrated into the directory tree. Understanding how and when file systems are mounted can help you understand the structure of your computer system storage. File sharing is a common requirement in nowadays systems, especially for collaborative work environments where access to files across different users is a common requirement. Hence, in most multi-user systems, we have individual user IDs for each user. These IDs are essential as they allow the system to set permissions and protections on a per-user basis, ensuring that each user has the appropriate access right to the files they need. Moreover, we also have group IDs. These are used to group certain users together, which is extremely useful when multiple users require the same access rights. By assigning a file to a group, all users within that group are granted the permissions associated with it. Here, every file within such a system has three main attributes concerning access: the owner, who is typically the creator of the file and has the authority to set permissions for the file; the group, which refers to the set of users, may be the same group as the file owner, maybe not; and others, which represents the rest of users in the system, who do not fall into the first two types. These attributes are fundamental in managing access to files, as they detect who can access a file. As we can see in the diagram, the circles represent different users group. We can group the user and set the privileges easily in this way. Here, we are going to focus on access control and groups within the file system of an operating system. When we talk about access control, we are referring to the method we use to control who can and cannot access certain files in a multi-user system. This is accomplished through something called an access control list, or ACL for short. The ACL acts as a checkpoint that validates each access request against the permission set for a file. Now, these permissions detect the mode of access, which includes three capabilities: reading, writing, and executing a file, often represented as RWX. Each file is associated with three classes of users: the owner, the group, and others, which we can also refer to as a public. Each class has a set of permissions expressed in the RWX format. For instance, an owner might have all permissions represented as 111 in binary, which equals to 7 in our permission notation. Group access might be slightly more restricted, set 111 in binary, which is 6. Meanwhile, public access is the most limited, perhaps just 001 or 1, allowing only execution. These permissions are crucial for maintaining system security and ensuring that the user can only interact with files in ways that they are authorized to. For example, using the chmod command, we can change these permissions. Here, we see chmod 761 game, which sets different levels of access for the owner, group, and public. On the right side of the slide, we have a typical long listing from a Unix-like system, showing this permission in action. This is what you will see when you list files with detailed information in the terminal. File protection in operating system, which is essential for maintaining the integrity and security of our data. The file owner or creator has certain rights and responsibilities. They should have the ability to control two critical aspects of a file. Firstly, what actions can be performed on the file, such as reading, writing, or executing. And secondly, by whom this action can be performed. This is where access control mechanisms come into play, ensuring that only authorized users can perform certain actions on a file. Moving beyond access, we must also protect files from physical damage to ensure reliability. This is where RAID comes in. RAID is a way of storing the same data in different places on multiple hard disks. By doing this, the system ensures that even if one disk fails, the data is not lost and can be recovered. Lastly, we have protection against improper access. This is often managed by assigned password to file or system, which must be entered before a user can access the file. Password add a layer of security, preventing unauthorized access and protecting sensitive information. File protection is an approach that includes controlling access, ensuring data reliability, and safeguarding against unauthorized access. It's a critical component of system security and data integrity.